Let us solve question number 5. I am marking this question. Calculate the magnitude, direction and location of resultant with respect to point A for a parallel force system as shown in figure. Here they have shown a parallel force system in which we have point A as the reference point. It is on 300 Newton force. Here we have to calculate the magnitude, direction and location of resultant. So what we will do, first we will draw the diagram again in the data. We will draw this diagram again. Here we have 1, 2, 3 and 4 forces inclined at 60 degree, and all the forces they are parallel to one another. Here we have 1, 2, 3 and 4 forces. We can say 100 Newton is inclined at 60 degree. So even 200 Newton is inclined at 60, 500 Newton is inclined at 60 and 300 Newton is also inclined at 60 degree. In other terms, all the forces they are parallel to one another. We have to calculate the resultant. That is a question. We have to find the resultant and locate it with respect to point A. So this is the question. How to solve this question? Since, as we can see in this diagram, all the forces they are inclined, and we know that if there are inclined forces, that forces have to be converted into horizontal and vertical form. You cannot solve it by considering the inclined forces. So first of all, there is 100 Newton inclined at 60 with horizontal. So its horizontal component will be, I will mark the components here. Its horizontal component, that will be force 100 inclined with horizontal, so cos 60. If it is with vertical, then it will be sin 60, cos 60. Okay, so here the horizontal component of 100 Newton force, which is inclined at 60 degree with horizontal, here it is 100 cos 60. Its vertical component will be 100 sin 60. Here we have resolved one force, then 200 Newton. Since 100 and 200 both are parallel, it means they are inclined at same angle, which is 60 with horizontal. So now for 200 Newton, I will first write its horizontal component. 200 Newton is also inclined with horizontal force. So here what I can say, the horizontal component will be 200 cos 60 degree and vertical component will be 200 sin 60 degree. Then we have 500 Newton force, which is acting in, you can say, in the upward direction. This force will also be inclined with, you can say, horizontal at 60 degree. So its horizontal component will be 500 cos 60. I can write it as this horizontal component, and here I have vertical component. Horizontal component I will write it as fx, vertical component with fy, and here I will write the value. Fx will be equal to 500 cos 60. I am writing the values separately to avoid the confusion in the diagram. Fy will be 100, it is 500 sin 60. Then we are left with the last force, which is 300 Newton. Again it will have its horizontal and vertical components. Here I'll mark its horizontal component as 300 cos 60. This will be 300 cos 60 degree. Vertical component will be 300 sin 60 degree. So now I have resolved all the forces and shown it on this diagram. Now we can easily calculate resultant here. As you can see in the diagram, these forces, they are composed of both horizontal as well as vertical forces. So resultant, you can calculate it by finding summation fx and summation fy. Here I will be writing, since sum of all horizontal forces is given by sum of all horizontal forces, that is summation of fx, condition clockwise, or you can say rightward forces positive and leftward forces negative. Therefore, summation of fx will be equal to, I will analyze one force at a time. 100 cos 60, this force is acting towards right, so positive. 100 cos 60. Next, the second force is 200. We have its horizontal component towards left, so minus 200 cos 60. Then 500 Newton force, its horizontal component is fx towards right and fx is 500 cos 60. Then we are left with 300 Newton force whose horizontal component is 300 cos 60 towards right, so positive. So if I calculate this, I will get my summation of fx answer as, that comes out to be, it is 350 Newton and the answer is positive. 350 Newton towards right because it is positive if I calculate all these values. After getting summation fx, now I will find out summation fy. So I can say that also sum of all vertical forces are given by, sum of all vertical forces are given by summation of fy is equal to, upward forces will be treated as positive, downward forces as negative. Therefore, summation of fy is equal to, I'll take 100 sin 60 as the first force, upward, that is why positive, then 200 sin 60 downward, so negative, next fy is upward, so positive, 500 sin 60, fy was 500 sin 60 positive, then we are left with 300 sin 60, that is also upward, so it will be plus 300 sin 60. Therefore, if I calculate all these values, I will be getting summation of fy as 606.2 22 Newton, and the answer is positive, that is why direction is upward. So once I have calculated summation fx, summation fy, now I can go for the calculation of resultant. Since resultant is given by capital R is equal to square root of summation fx whole square plus summation fy whole square. We have this formula to calculate the resultant, and therefore we can say capital R is equal to square root of summation fx. My answer was 350 Newton, 350 square plus summation fy 606.22 whole square. Here if I calculate my value of resultant, that will be 700 Newton. This is my first answer. I have got the value of resultant. Now after getting resultant, I can even find its location. Location of resultant is given by it can be calculated as theta is equal to tan inverse of summation fy upon summation fx. Therefore, theta is equal to tan inverse of summation fy, that was 606.22, summation fx 350. So out of this I get my theta value. If I calculate all terms here, tan inverse of 606.22 divided by 350, theta comes out to be 60 degree. Means even resultant is at 60 degree inclination. Now you can even locate the resultant by drawing the axis. Positive x, negative x, positive y, negative y. Since I have my fx value as positive, fy value is positive, resultant will be in this first quadrant, inclined at 60 degree to the horizontal. Resultant is equal to 700 Newton. Theta is at 60 degree. So we have located the resultant. Now if we want, we can even locate the resultant with respect to point A. We know that it will be inclined at 60 degree, but we can even calculate its location from point A. Like we have location of 500 Newton with point A, it is at 1 meter. Similarly, you can find the location of resultant. I can write down also by Varignon's theorem of moments. Summation of moments about point A is equal to the moment of resultant, where clockwise moment to be considered positive and anti-clockwise moment to be taken as negative. Therefore, if I calculate this at point A, since the first force is 300 Newton and it is passing through A, no perpendicular distance between 300 Newton and point A, so the moment of 300 Newton force would be 0. So at first I am getting 300 into 0. Next, 500 Newton force, if I take the moment at point A, if it reaches point A, it will be reaching in the anti-clock direction. So here I have minus 500 into perpendicular distance is 1, minus 500 into 1, then 200 Newton is acting at 2 meter from A, it would be moving in clockwise direction. So plus 200 into 2. Then 100 Newton is acting at 3 meter from A, it will be producing anti-clockwise moment. So that is minus 100 into 3. Resultant, we know that resultant, the answer which we have got, it was 700. So I'll write down 700 into x. So if I calculate all the values here, this left hand side, and divide it by 700, I will get my answer of x, which is 0.57 meter with respect to point A. This is my second answer. So it means if here we have point A, in between point A there will be a point called as 0.57 meter. I can show it separately here like this. If I have a force of, if I have this as point A and here the force is 300 Newton, so with respect to point A there is a resultant. This in red color which I have shown, this is the resultant whose value is 700 Newton and it is located with respect to point A at x is equal to 0.57 meter, and the inclination is, as we have seen, it is 60 degree. And with this we have completed the question.